work on leetcode 1074. This is also a hard question. The number of submatrices, the sum to target. So the question says that we are given a matrix and a target, and we want to return the number of non-empty submatrices, the sum to target. So there are two examples here, and we can have a more detailed discussion. For example, if you see this example, and we have this matrix, and each position has some integer, and we have a target 0. So the way we get a square, get like a submatrix submit to target is just these 4 different kind, right? We can only choose this corner and this corner, this corner, or this corner. So in total, 4 different kind of choices. And if we consider this case, it has 1, -1, or -1, 1. So the way we choose is 1, -1, and -1, 1, right? We can choose this way, or vertically this way, or vertically this way. And we can choose the entire matrix. So there are in total 5 different choices. Yeah. And here is also an example that there's no valid choices, so we output 0. So let's see the constraints. The matrix length is 100, right? This length, it has 100 rows and also has 100 columns. So remember that for matrix and similar questions, we can pre-compute some pre-sum, right? For example, if we have all the pre-sums in 2-dimensional, and for each pair of x1, x2, and y1, y2, we can get the summation of some submatrix in a constant time. However, this is a naive choice. Let me write it down. So naive solution is to calculate the pre-sum in 2D, then get sum of x1, x2, y1, y2 in constant time. But this will not be enough, or at least it's not the optimal solution. So because we have 100, 100, so the time complexity will be on the order of n to the 4th, right? It will be 10 to the 8th. So this could be a big problem. So the way we do that is we still compute the pre-sum, but we just compute the pre-sum for each column. Then for every combination of x, y, and what we do, our algorithm is pre-calculate pre-sum of each column. Okay, then for all combination ij, row ij, we can do the following things. So we use a hash to do as the pre-sum to count mapping. Then for each y position, for each y column, then we use hash to get the count of y minus target. In this way, we will know that if we have the count of y minus target, we immediately know there are count number of ways to form target, because y minus this value will be target, right? That is a segment of the summation. Then we are done, right? So then result should be plus we add count into result, then we return the final value. Okay, let's write the code here. So in order to do that, we need a pre-calculation of pre-sum of each column. So we still need a matrix the same size as this given matrix. So we say this one is column sum. So we call that C sum. So then we remember those matrix information using n and m. N is how many rows and m is how many columns. Then C sum is with the same size, so n and m. The initial value are 0. So for each one, each position in the matrix, we can do the following things. For j equals 0, j less than m, j. If I is equal to 0, then what we do? C sum ij will be equal to matrix ij, right? We don't have a previous row to add. Otherwise, C sum ij will be equal to C sum I minus 1 j plus matrix ij. Okay, then we got all the C sum. Remember, we do the next step. So for all combinations of row, we first define the return value, and for all combinations of row, so I is from equal to 0 until we have in total n rows, and for j it starts from I, because we can start from I and end with the same I, just one row, right? Then j is also less than n because we have n row. Then we increase j. Inside this for loop, we do the following things. We first make a hash table to get all the pre-sums. Hash is on an ordered map from int to int. So this is pre-sum of column from I to j, right? And mapping to a count. Then we first remember all those. We can remember all those pre-sums. For example, we use a vector to remember it. Pre-sum. We just call that pre-sum. I would just call that numbers. Okay. And it's m 0. And for int k equals 0, k less than m, k plus plus. Then if I equals 0, nums k equals C sum j k, right? Because if the I is equal to 0, then this column sum is just the value we want to put in nums. Otherwise, nums k equals C sum j k minus j I minus 1 k. Okay, this is a situation where I is not equal to 0. Then we have nums. Then we can do the actual work. We first define a pre-sum. It is 0, and we loop over from k equals 0 until k less than m. And for each value inside this nums, if k is equal to 0, we first update pre-sum. Pre-sum is previous value plus the current value. Then for k equals 0, if pre-sum is equal to target, then we update the result. And then we update hash table. Hash pre-sum should be increased by 1. Okay, otherwise, we still need to update pre-sum. So we update it outside this if else. Then T will be pre-sum minus target, right? And if hash count T, then we add its count into res. Then we update hash, because this hash will be used by other positions as well. Now I think we are done, right? We will just return the total value of res. Let's try. We have an error. Okay. Let's see what's missing here. So at beginning we define n and m, then we define the column sum. It's n times m. Then for I equals 0 to n, and for the outer position in J, the C-sum ij equals to matrix ij if I is equal to 0. This is just the first row, right? And for all other rows, C-sum ij equals C-sum I minus 1j plus matrix ij. Okay, it seems right. And for this part, we define the return value, and for all combinations of I and j, that is indicates this is the row from I to j, right? So we define nums to contain all the values. If I equals 0, then nums k just equal to column sum jk. Otherwise, nums k will be equal to column jk minus c-sum I minus 1k. Okay, it's just a segment between I and j for each column at position k. Then we do the actual work. So we initially put pre-sum to 0, and for each position of k, we first update pre-sum. Then if k is 0, we see if pre-sum is equal to target. If so, we add 1 to the result and update the hash. Otherwise, so for cases k not equal to k, and first we also update pre-sum, right? Then t is the value we are looking for. We will count how many times t is in hash. And then we update res using hash t. Then what we are doing is we update hash by 1, because now the new item is pre-sum. It seems correct, so let's see. So this one is wrong. This one has a target should be output should be 37, but should be 43, but we output 37. Let's see. J is correct. And M is the column, right? This is right. And now I is the row and J is the column. I is row, J is column. And finally, we return res. I think this is the one we are having problem. Let's output the csum first to see if we did that right. I equals 0, I equals less than n. For j equals 0, j less than n. Csum I, j, and now we can see if this is correct. Yeah, this is correct, right? So for first row it's 1 minus 1. The second row should be all 0. So we know it's this part having some problem. I don't find any issue, right? So the way to debug is actually output all those values. For example, we can output the value in nums to see what's happening. For 0, k less than n, k. So we should expect -1, 1. I don't think this is correct. So we have first time we have I equals 0 here. So we have csum jk. J is 0 actually. So we actually expect 1 minus 1. What's the problem? So we actually expect 1 and minus 1 for first time. And also for second time it seems that it's just output once, not twice. So let's output ij. Okay, so ij, the first time is 1 minus 1. Second time is 0, 1. Third time minus 1, 1. Yeah, that seems right. Okay. And why don't we have the right answer? We use the hash, and we hash also presum. So we see that for this case, we should be able to get the result should be 1 after the first loop, right? Oh, result is 0. So there's some problem here. So if k is 0, then presum is not equal to target. So we just update presum. Presum is 1, right? And then we have this function here. So the update. So I think we missed one situation. If presum equal to target, then we still need to add 1 to RES. It's similar to the situation for k equals 0. So yeah, I think that is correct. So the situation is we need to consider this target is formed just by presum. It's not by some places minus another place by the difference of 2 presum. So if in this case we should consider if presum is already equal to target. If so, we can add 1 to the RES. Then we delete all other outputs, and hopefully we can pass this time. Okay, and 26. Run again, and there's no output. Okay, that's some. Yeah. Okay, finally we passed. And I think the main issue is we need to add one more here to presum equal target. Okay, and that's it. Thank you, and see you next time.